Hello.
Hey Joaquin, how are you today?
Good, how are you?
Good. Did you get today off or is that upcoming?
Upcoming. We have Thursday and Friday off.
Nice. Any plans? You guys going anywhere, doing anything fun?
I'm going on a class trip to Disneyland, so that's fun.
That's going to be fun. Have you looked at the weather? All everything look good heading out that far?
It's it's supposedly supposed to rain all day while we're at Disneyland.
That does happen. Now, the good news is there will not be as many people if it rains all day.
That is true.
Yeah, you got to you got to look at it like what's gonna now you is there like are you going to be do a group thing? Do you go on your own? What's your kind of mindset once you get there?
I would like to go alone, but we have to stay together because school regulations and stuff.
Okay.
Um, but yeah, that's it.
Have you been there before? Or is this a first time?
I went freshman year, but I haven't gone back since, so this is really fun. I'm really
Cool.
excited.
Cool. Yeah, that's awesome.
Sorry I wasn't at the SAT thing. I had a Vex competition.
Great. How'd it go?
We lost.
Oh, you gotta if you're gonna miss, you gotta win. Tell me we took first place. That's all right.
We were sp-
Did you have a good time though? Did you learn something maybe more importantly?
yeah, we taught one of the teammates how to drive since the two drivers right now aren't going to be here next year because we're both seniors.
Hmm.
So we taught him how to drive, and then we figured out what was wrong with the drivetrain and why it was like drifting so much. So we fixed that in the like first 30 minutes of the competition, which was really nice.
That's great. That's great. Fixing stuff on the fly is a lot harder than when you go back home but there's also that pressure there of like, hey, we better fix this. We better figure it out real quick.
True. Yeah.
That's awesome. Okay, well, let's jump right in here to what you want to work on today. Do you have certain problems? Let me see, maybe you said that in the email. Uh, okay, 8.3 today, 12, 15. All right. Yes, we can work on these. Do you have that reference sheet from last time on conic sections? If you don't, I'm going to send it over to you in the chat again. We're definitely going to need that today.
Okay. I think I do, but I can't seem to find it.
All right, we'll throw that in the chat. Where's your teacher stand on formula sheets? Any good news out of that? Um, any
Not
discussion?
good.
Not good. Probably got to memorize everything, right?
Yeah, we got to memorize everything. He was telling us today that we're not allowed to, or he's not going to give us a worksheet with all the equations on it.
Yeah. It's kind of the worst situation imaginable. But that is nevertheless what you have in front of you. So at least you know. Um, but we're going to use the equations. I mean, there's no way to do this without having the equations. So we'll just assume you've memorized them. But let's get started here. So I'm going to share my screen and we'll take a look at, looks like number 12 is the first one you want us to look at tonight.
Yes.
And the instructions here say to find the vertices, the foci, the equations, the asymptote, and sketch the hyperbola. So the current form of this is quite awful. It's not anywhere close to what you want. So you always want one. You always want one on the right-hand side. Okay.
Right.
So you divide by minus 16. You divide both. It's not a choice. So this becomes negative y squared plus x squared over 16. And then we really want to rearrange this. We really want the positive one to come first. So I'm going to rewrite this as x squared over 4 squared minus y squared over 1 squared equals 1. Does this look like some things you were doing in class?
Yes.
Good. Okay. Now, the next thing is to know which one is it. And yeah, I'm very heavy on the formulas because I just don't know why you would ever ask someone to do this without it. But the you can see it again. It says vertical versus horizontal, but notice the order. Notice that x squared comes before y squared. and then y squared comes before x squared. So it's really critical that you know which one we're doing, and it is this one on the right here. Is that okay? Is that clear?
Yes.
All right. Now, again, like just like last time we had a lesson, there's now 5 things that you need to know to be able to do these problems. You need to know H, K, A, B, and C. Can you tell me H and K?
Um, 0 and 0.
0 and 0. Now A, you gotta be careful here because like you're gonna have to know both of these. So notice you gotta look for patterns here. So notice A is in front of the first term in both cases, or is the bottom of the first term. So A is 4 in this problem. B is 1. And then to find C, again, there's just so much here. You have to know this relationship right here. A squared equals B squared plus C squared. Why is that? I don't know, but just you'll have to, because it's not the Pythagorean theorem. It's kind of off. So
Right.
one of the things you should always get though is a positive number. So if you ever get a situation where your answer for C is like negative square root of 8, you've probably made a mistake. And it is normal for the C squared to not be nice. Like in this case, it's the square root of 15, which does not work out as anything useful at the moment. But you got to find these 5 values. You just have to. Like that's the key to doing these problems. That unlocks everything else along with knowing the equations. Any questions so far? Anything?
Um, no.
Okay. So first thing here is the first one here is the center. Even though a hyperbola looks weird, they do have a center. Okay. The next one is the vertices and the foci. This is most similar to parabolas in some ways. Okay, so
Right.
you just have to use these numbers 0, 0, and then H plus or minus A, comma K. So there's actually 2 points for this one. It's going to be 4 and negative 4, comma 0, comma 0. And then for the next one here, it's square root of 15 minus square root of 15, comma 0.
Okay. Um,
Hang on a second. I hope I didn't give you the wrong equations. No, those are right. Sorry, I got
um,
question.
in class,
Yes,
um, oh, sorry, my eye is watering. I don't know why.
allergies are bad, real bad.
Probably in class, he did C equals A plus B, but I don't think that would change anything.
That is not correct. That's completely wrong. So please double check that.
Because he in class he said it was C equals A or C squared equals A squared plus B squared.
That is true. That is just C squared equals. Oh, I'm sorry. Yes, I gave you the wrong one. I'm sorry. This is from. Yeah. So just to be clear, it's C squared equals A squared plus B squared. And
Okay,
yes, that is correct. And
so that
I'm
would change the problem, right?
slightly. It makes this C equals the square root of 17. I mean, we're not talking about a major shift, but I apologize. I was looking at the wrong formula for these things. There we go. Okay. Yeah,
Okay.
sorry. When I said it was wrong, it was the whole squared part. I was like, that just can't be right. If it doesn't have a square.
Yeah.
Okay,
Thank
so
you.
now, so now we also need the asymptotic equation. They call them the asymptotes. Again, just having the formula really helps. It's y equals, again, in your case, k is 0, but it's plus or minus b over a 1/4 x minus 0, or just 1/4 x.
Right.
Now I think they teach like maybe a box method to graph these things.
Yeah, my teacher did the box method.
Yeah, so you first start by graphing the asymptotes.
Okay.
At least I think that does that sound consistent with what you guys were doing or not? Or did you do the vertices first?
We did the center and then the vertices first, actually.
Okay, so there's the center. Vertices, you're going 4 right, 4 left. Okay. Now the box comes from the line here. So 1/4, you got to look at this, really got to break this apart as two equations, 1/4 x minus 1/4 x. So that puts you, these are asymptotes, they're kind of like that. And then minus 1/4 x is going the other way. Didn't quite get that right. Okay, like that. And so from here, your foci are going to be inside there, but this is the box. Well, the box, I guess, is this. Is that what you guys are doing?
Yeah.
Okay. All right. So I mean, I don't really know that you need a box, but you need to graph these things with some correct nature.
I'm sorry. I'm gonna go blow my nose real quick.
Yep. Yep. Do what you need to do. Let me know when you're back.
Sorry, I'm back.
No problem about that. So, again, it's probably always good to go to like Desmos and graph these as well, just to get a feel for, if you're on the right track, especially if you're doing them on your own.
Yes, sir.
And why do I feel like we did this completely wrong? Oh, because I don't have a squared there. Okay. Yeah, we've got it. Any questions on this or anything, comment, follow up?
Um, when we did it in class, we didn't learn about the asymptotes, but I think that kind of helps.
It's so much easier with them because it has to. I don't like the box method, so I was asking about that. The asymptotes frame it. They frame because it's got to hit at, because the vertex from parabolas got to hit. So it's like it boom, it's there. The only thing this is missing are the foci, which you can add in if you want. But I think it really does a nice job there.
Right.
15, we should do 15 next. Conic sections. Okay. So kind of the same situation as the previous problem. You got to find HK, A, B, and C. A is always, I don't want to say this. A is always under the leading term, the leading one, as long as it's positive and then negative. So
Okay.
this is gonna be a squared, this is gonna be your b squared. So give me a h, k, a, and b. And then we also want you to solve for c with c squared equals a squared plus b squared. Let's go ahead and give me those values whenever you have that.
H is 1, K is 2, A is 3, and B is 4.
Yeah, now good job there with h and k. So h always goes with x, k always goes with y.
Right.
So c is a squared plus b squared, which is 3 squared plus 4 squared. That's 25, so c is 5. That one worked out nice. Okay, so next, so this one is the vertical transverse equation. Not that that matters too much, but I'm gonna snip this in here. Okay, so the equation, really nice to have the equation, but notice it's in this nice form here. The center we have at 1, 2. The vertices are at h, 1, and then 1, and then k plus a. So we've got 2 plus 3, that's 5. 2 minus 3, that's -1. And then your foci are at h, k plus c, so that's 7. K minus c, that's -3. And then what I feel is probably the most important is this asymptotic equation. K 2 plus or minus 3/4 x minus 1. And we'll talk about what to do here with this in a moment, but
Okay. And the why are the vertices different again? Can you explain that again?
there's two of them. One of them is k plus a, and the other one's k minus a.
Oh, okay.
So 2 plus 3 and then 2 minus 3.
Okay. And I'm guessing for the foci, it's the same thing.
Yes.
Uh,
Because this one ends up opening up and down. So there's got to be 2 vertices and 2 foci.
okay. Just checking. Thank you.
Good question. Okay, now we noticed, we just learned that the real key to this is to use the asymptotic equations. So 1, 2 is our center though. Let me do that here. So 1, 2 is your center. Now this asymptotic equations, it actually is in point slope form, but it's kind of not quite right in point slope form. Let me show you that real quick because I think it could really save you time here. So y minus 2 plus or minus 3/4 x minus 1. So what a lot of students don't remember is when it's in point slope form, you go to that point, which happens to be at the center right there, and then you use the slope as your line to go from there. So what I mean is you're going to go up 3 from there, right 4. Okay,
Mhm.
and that's your, see if I can get this right here. This is your one line. Okay, so you don't want to get caught up in like adding, distributing, combining like terms. You actually just go right to the point, which just happens to be the center, and then you do the one that's negative 3/4 down 3, right 4. Okay, and then you've got your two asymptotes without much work there. So you use the point 2, 1, no 1, 2, sorry 1, 2, not 2, 1, and you basically, it's the center, so you just use the coefficient as the slope in both directions. The next point I would plot is the vertex. So that's at 1, 5 and 1, -1.
Mhm.
And I mean, frankly, that's enough. I mean, you know, this thing's gonna do that. And then down here, it's gonna do the same
Down there.
thing, same thing. I mean, there's not much, they're not asking for specific points. So your instructor wants to see the shape like that. It's like open up, open down. They want to maybe see the points labeled, you know, for the center and then for the vertices, and I should label the asymptotic equations, label the foci, you know, here's the foci, here's the other foci. That they're just looking to see if it's kind of close. Does it pass the eye test, basically?
Right. It's weird but funny.
Yeah. Any questions on that?
No.
All
No.
right, so 18 is a completing the square question. Has that been covered in class?
Yes.
Okay. I'm going to show you an approach that you may or may not have seen in class. So just you know, keep in mind that might be a little different. I'm going to write the first two x terms, leave a space. Then I'm going to write the y terms, leave a space, and put the minus 92 on the right.
Okay.
Now this, again, this is probably not exactly what you've seen in class, but I think you'll like my approach. So it's not, I'm going to factor out a 9, it's x squared plus 8x, leave a space like this, okay? Now we got to figure out what goes in this bucket right here, this position. And the answer is it's half of this number that I'm circling, 8 squared. Okay, so you generally say, okay, it's x plus 4 squared. You're taking half, but then what goes back here? It's the last number squared. Is that right? Do you catch that?
Yeah.
So that's plus 16 in that position. Now, to go back up to the previous position, okay, the truth is that, oops, sorry. There's actually a little bit more here. This bucket that's right here, there's also a bucket right here that's the same. So the red one ends up being 9, this 9 over here on the left, 9 times 16. Like imagine multiplying 9 into each of these to go back to the previous line. And that's 144. So you have to add that to both sides. Okay, now we're ready to move on to, and then this 9 comes down. Now we're ready to move on to the y's, okay? So you're going to factor out the -4. This becomes y squared plus 4y plus a little bucket here. And then what goes down here in this binomial? It's half of this term 4, so it's y plus 2 squared. Again, you take half, but then you square to go back. So 2 squared is 4. Again, kind of like the last one, the bucket here, whatever goes in this position, also goes in this position over here. So it ends up being whatever this this -4 gets multiplied. So -4y squared. So yeah, that's the previous term. -4 times 4y is -16. -4 times 4 is -16. And it has to match. It's sharing. It's like, you know, everyone gets to ride the same ride at Disneyland.
Right.
Maybe. Okay. So from here on, I'm going to bring this -4 down. On the right side, you got to add up all those numbers. So it ends up being I think it's like 36. Does that look okay to you?
Yes.
Okay, now standard form doesn't have a number on the right hand side. It's got to be one. It can't be anything but one. So you have to divide everything by 36. So this becomes x plus 4 squared. Now on the bottom, 9 divided by 36 is 1/4. So I like to write it as whatever it is squared to help me with my a, b, and c. Same thing with this next one. 4 over 36 is 1/9. So that's really 3 squared on the bottom. Like that. And now it's just like a problem we've done. H, K, A, B, and C. So the completing square just gets you back to something that you're now supposed to already know.
Right. Interesting.
Okay, so I want you to give me H, K, A, B, and C, please. Whenever you're ready, take a moment. Need to get caught up.
H is -4.
Good,
K is -2.
good.
A is, would A be 2?
A always goes with the first term. So yeah, A is 2.
And then B is 3,
Mhm.
which makes C 5 again.
It's C squared equals A squared plus B squared, Pythagorean theorem. So 2 squared is 4, 3 squared is
Oh.
9. It's not great, but it is what it is.
Right. Okay.
Okay. So once you have these things, this one is the I don't want to say this. It's the horizontal transverse axis. I don't really think that is super meaningful, but the reason again is it's because the x squared is first. It's positive here. It's not subtract. So center, we'll do the center first. Center is -4, -2. So that helps you to figure out where you're going to start your graph. Then the vertex, vertices, h plus or minus a. So that's -4, -2, -4, -2. So that's -6. And then k is -2. And then it's -4 plus 2, or maybe I did that backwards, but as long as you get both of them, I guess it doesn't really matter. And it's okay if you want to write them out. I'm just limited on space here.
Right.
So the next one is h plus c. So this one doesn't work out nice. It's -4 plus the square root of 13, comma -2. -4 minus the square root of 13, comma -2. Yeah, it doesn't mean much. Doesn't mean much to me, but
Could
you
we
just
do -4 plus or minus square root of 13, comma -2?
sure, if your teacher will take that, fine with,
Yes,
yeah,
that's the foci, right?
yes. Foci. For plural of focus is foci. I don't make the rules, just to keep that in mind. So this asymptotic equation is k is -2 plus or minus b over a 2/3.
No, wouldn't it be 3/2?
Yes, thank you. Thank you. 3/2 x plus 4. And don't take too much again. Don't take too much away from this. It's in point slope form. All you really care about is this plus or minus 3/2. That's the rest of it's going to start at the center.
Right.
Okay, ready to graph this one?
Yes.
All right. It may not have gone far enough here. Yeah, I guess this will work. Okay, -4, -2. No, +2. That's why it's not gonna. No, it is -4, -2. I'm so sorry. Okay, and then from here, you're gonna you're gonna start from this point. You're gonna go 3/2 up 3, right 2, and then you just get that other place there for the first asymptote, and then you go the other direction, down 3, right 2, same thing there, like that. Okay.
Okay.
Okay. And that but here's what you don't know. You don't know, like, well, is it this, or is it, which one is it? And that's why, excuse me, you need the rest of the stuff. So that's where we go to the vertices next. So -6, 2, that's here, -2, sorry. And then -2, that's here. And that then tells you that what it now looks like this. And then if you need to, you can add in the foci.
Okay. Yeah.
Again,
Why,
oh, sorry, go ahead.
why is the foci near the y-axis? Shouldn't it be uh
I didn't really put it in a great spot. I mean, it's square root of 13 is between 3 and 4, so it's -4 plus like 3.5, so it's probably around -0.5,
oh, okay.
roughly.
Okay. Just wondering.
The thing I wanted to say here is, like, if it feels like I'm making this look easy, it's because I have the formulas. Like, and one strategy here is to write down the formulas on the first sheet of the test or a piece of paper, like when you take the test. That way you've got them all.
Right.
That would be a good strategy, because then you're just doing exactly what we've done. Now, that does require you to memorize them, but you've probably noticed some patterns if you doing enough problems, I'll say.
Right.
What's kind of your plan to for this? Like, do you feel like you're going to memorize? What are you thinking?
Um, I'm gonna memorize most of the patterns of how they work.
Okay.
Not really the formula itself.
All right. This won't be the last time you'll have to, get a bunch. You're not by chance an actor where you have to memorize a lot of lines or anything like that?
Actually, I am. We have a show in like a week, and I'm
So,
not ready.
okay. So I'm just started reading William Shatner's book. You've probably heard of him. He's a older movie, TV show. And
Yeah, I think so.
but I just started reading his book, and that's one of the first things he talked about being successful was his ability to quickly learn lines. He was doing a play a week when he was a little bit older than you, in his 20s. So it is possible.
It is possible, but
Yeah, it's hard.
it's a lot of work.
Yeah. And the reason I went there is I just thinking that you gotta memorize a bunch of stuff there. I know you play off other characters, but that would be something to think about how you maybe can apply some of those strategies to this.
Yeah.
All right, so this one is another completing the square problem. Gonna group the y terms and move the constant over. So because there's only one y squared term, there's nothing to do with y. Y is already settled. So we do have to deal with these. So I don't use formulas. I do it kind of this more algorithmic way, but I think it works pretty well. So I factor 2 out of both terms, and then you need half of -4. So that's x minus 2 squared. That's 1/2. And then you square, that gives you +4. Okay, but again, and I like the color codes, I think really help here. Whatever goes up here in the original line also goes back over here on the right, the balance. You have to be fair.
Right.
So
So I mean,
what would
at
go here?
8. No.
Yes, you have it right. Because you're multiplying in 2x squared minus 8x plus 4. So that does in fact work. Okay, bring this 2 down. Minus y squared equals 4.
Yeah.
You divide everything by 4. So this is x minus 2 squared over 2 minus y squared over 4 equals 1. Now this one's a little awkward because you have to remember that you can square a square root. Like that. So your a is actually the square root of 2 this time. Okay. From here though, it's just very formulaic. H is 2, K is 0, A is square root of 2, B is 2, and then C squared equals A squared plus B squared. So that's the square root of 2 squared plus 2 squared. So 2 plus 4, C is the square root of 6.
Okay.
Do you dislike that? Anything unclear about that?
Yeah. Can you scroll up a little bit?
Of course,
Why'd you divide by 4?
the right hand side has to be 1. Has to. So in the both the ellipse and hyperbola, the right hand side is always 1. Or left side if you flip these, but that's just a requirement.
Okay. Okay. Thank you.
Yeah. So now it's just using the formulas again. So the center is at HK. That's the same for both. Okay. So that's at 2, 0. Then the vertices, this time they're at H plus or minus A, K. So that becomes 2 plus or minus the square root of 2, 0. The foci are at H plus or minus C, K. So that's 2 plus or minus the square root of 6, 0. Ooh, these are not good. And then perhaps worse are the asymptotic equations. K plus or minus B over A, X minus H. Okay, so the K is 0. So it's plus or minus B2 over square root of 2, X minus 2, like that.
Yeah.
But don't overthink it. I mean, don't get all like worried, like, what am I gonna do with the square roots? I mean, you just want the right look, the right shape of it. Yeah, it's like worrying about your something on the set and, you know, the person in the back row can't even see it. Just get close enough, make it look right. So we start at 2, 0. Here, 2, 0 is the center. Is that right? Yeah. And
Yeah.
then the equation, you start right there. So what do we do with 2? Well, we go up 2, and then we go right square root of 2. So you got to have an idea of where square root of 2 is. So on a number line, there's 1. That's the square root of 1. There's 4, which is, I'm sorry. There's 2, which is the square root of 4. Forget about that 4. So the square root of 2 is like, it's between 1 and 2, but is it closer to 1 or is it closer to 2? Your
Can you
opinion.
say that again?
So I'm trying to show you in a number line that 1 is square root of 1 is 1.
Right.
2 is the square root of 2. Square root of 4 is 2.
Right. The square
Where is
root
this?
of
Is the square root of 2 closer to 1 or is it closer to 2?
1.
Yeah. So if you go up 2, you're going like a little more than 1. And that's, I mean, that's how you sort of estimate where it is. You know, you want to be in the world of reasonable when you're doing this. Similarly,
Right.
when you go down, you're going, you know, right square root of 2 roughly. And just so that it you know, it's got the right closeness. Okay. Then you graph the vertices. So this one's also again tough. It's like, what is 2 plus the square root of 2? Well, we said it's a little more than 1, so it's like maybe 3 and a little.
Right.
And then 2 minus square root of 2, it's like 2 minus 1 and a little bit, so maybe it's like 0.8-ish, you know, right in there.
Okay.
And then you can add in your foci. So square root of 6, we know that 3 is the square root of 9. So the square root of 6 is going to be like a little bigger than 2.
It's gonna be like in the middle, isn't it?
Yeah, you can go middle. That's fine. Like, so it's 2 plus 2.5. So like 4.5 right there. 2 minus 2.5 minus 0.5. Fine.
Huh. 2.
24, we got just enough to, oh, another completing the square. So what we have not done are any of the going backwards problems. And the going backwards problems, we did a couple of those last time. It's where that's the grouping of like 27 through 42, where they give you the information. You got to find H, K, A, B, and C, and then write the equation from that. But we got probably just enough time to here to do 24 for today. So group the Y terms in this case, because they come first, leave a space. Minus x squared equals negative 12. So you move that constant over. You always, whenever you do this completing the square stuff, you always have to backfill something in there, and we'll figure out what that number is. But there's these buckets that are going to be filled in both sides there. So that I like to factor out the leading term. So y squared minus 4y. Again, leave a space. What goes in the next line here?
1/2 of 4 is 2.
So minus 2. The sign, it keeps the sign.
Right. Minus 2.
Okay, and then what you go back, what goes back?
Squared, so positive 4 plus 4.
Okay. And then this last one though, you're going down and then you work your way back up. Remember, you're multiplying in each of these.
plus 16?
Plus 16, very good. You gotta be fair. So you're gonna put that over there. Minus x squared equals positive 4.
Right. And then
Can't have 4 there. We need a 1. So you divide everything by
4
4. So it's y minus 2
squared.
squared, 1 squared minus x squared over 2 squared equals 1.
Okay.
So now you have to find h, k, a, b, and c for me, please.
H is 0, K is 2, A is 1, and B is 2.
Okay.
And then C would be 1 squared plus 2 squared, so 1 plus 4 is 5, so square root of 5.
Yes, good. Right, so the this is the vertical transverse axis. I'll snip those equations in and we'll write them out here. Yeah, that scales so poorly. Okay. So the center is going to be 0, 2. Vertices are going to be at 0, k plus or minus a. So we're going to have to go 2 plus 1, that's 3. 2 minus 1, which is 1. The foci are at 2 plus or minus the square root of 5, like that. Asymptotic equation 2 plus or minus a over b 1/2 x, like that.
Okay.
So quick sketch, of course. We go to that center, 0, 2. There it is. I'm actually going to move my graph down a little. 0, 2. And then, so we go to that point and we go up our slope, up 1, right 2, up 1, right 2. So something like that. And then go the other direction. Like that.
Yeah.
Get your vertices 0, 3, 0, 1. And then you got the shape of it. Foci, 2 plus the square root of 5. So the square root of 5 is like a little bit bigger than 2. So 2 plus 2 is like 4, a little bit more than 4. 2 minus 2 is like a little bit negative. Something like that.
Yeah. Yeah.
All right. So that's